But how are we going to start to understand this most incredibly complex machine and gain appreciation of it? Possibly the most in the entire universe, that we know of. So to put a little bit of history on it, we're in a very lucky time. Because of technology, communications, we've learned more in the last 100 years than in the past 5,000 years. You go back to the papyrus in Egypt, there are descriptions of brain injury from war. It wasn't until Aristotle, about 350 BC, felt that there's some vitalism in the body. He called it an entelechy. He didn't know if it came from the heart, the brain, nobody really knew. And it wasn't until 1906 that two scientists, Camillo Golgi and Santiago Ramon y Cajal, won the Nobel Prize for understanding first what neurons are. Camillo Golgi came up with the Golgi stain that allowed us to start to see neurons. So let's flash forward 100 years. 1906, we're 100 years later. We've gone from just understanding what a neuron is to understanding tensors, networks, other complex things. So in order to understand the brain, we involve many disciplines. There are the medical ones, there are the anatomy ones, the physics ones, and philosophy and religion. We can't forget all of these types of things that are all critical involved. And there may also be other things of which we're never going to understand or even capable of understanding as humans. So we have to put all of this together to try to figure out what it means and furthermore, explain it to other people. I like analogies. I always think in analogies. Analogies help us. And not just in telling stories to people. This is on the left. In the past, I've used these quite a bit, years back. Things like called Laplace transforms, Hamiltonian transforms, Z transforms. What are these? There are some formulas that are so incredibly complex in the real world, integrals, other equations, it's very hard to solve. But in what's called imaginary plane, complex variable plane, they're easy. So these transforms transform what is hard to understand into a plane that we can solve it, and then we transform it back. And that's what analogies are. We may have trouble comprehending one thing, but we convert it to something that we are understanding a little bit easier. So a little bit about myself. I grew up in New York City. My training initially, degrees in physics with electrical engineering. I worked at IBM for a little bit. Actually, I originally knew the one thing I never wanted to do was go into medicine. Never. That was the one thing I knew I did not want to be. My mother passed away when I was 15. She was ill for the last 3 years, in and out of New York Hospital ICU with emphysema. So I've been in enough ICUs and emergency room. I knew I never wanted to go into medicine. But I kind of fell into it. I kind of ended up volunteering, actually in the same ICU she passed away, and I felt this magnetism towards taking care of patients and people. And then I just fell, and I thought since she died of emphysema, I wanted to be a pulmonary doctor, do research. That was actually how I chose medical school. I went to a place that did one of the best research in emphysema. But when I was introduced to the brain, I said, no, this is for me. This is enough to challenge me and fascinate me for life. So after I did my residency in neurosurgery in St. Louis, fellowship in vascular and skull-based surgery in Phoenix, I'm board certified by American Board of Neurosurgery, and I'm life care planner. I've had past faculty appointments at University of Texas for about a decade in the past.